Good morning, students. Right, after Pongal, like yesterday that we celebrated as Sankranti. So, what it is basically, Sankranti means this is a day after which our days will be, the length of the days will start increasing and the length of the night will start decreasing. And the sun will go to its peak, like the brightness and the hotness of the sun is going to increase and it will go up to summer. Okay, and then it will start decreasing. So this is the time in which we say that the amount of energy that the sun is giving us is increasing day by day. So what we should pray? We should pray that the way the sun is increasing, the same way the brightness, okay, or the energy in us also increases. That's why we pray a Sankranti or Pongal. Okay, so let's pray that as the sun is, the energy in the sun, the energy with which, or rather the sun is sending to us, we also can grasp more energy and we can also work accordingly for our own goal or mission. Okay, so with that, let's start then the chapter called Center of Mass. For a few students, little bit of revision will be there initially, 10 minutes, 15 minutes, and then it will be a regular class on Center of Mass. Okay. So Center of Mass, basically, it reflects what? It reflects a point within the body or outside the body. Okay, where we can assume that the entire mass of the object or the body is concentrated. Okay, what is the definition? A point inside or outside the object where entire mass of the object is assumed to be concentrated. Assumed to be concentrated. Okay, a point mass where entire mass of the body is assumed to be concentrated. That's called center of mass, right? And okay, there is some point where, but what is the need? What is the need of assuming such point where entire mass we can assume to be concentrated? What is the need? Because previous chapters, whatever we have done so far, okay, kinematics is there, laws of motion is there, friction is there, work energy is there, circular motion is there, where we never considered this. So why it is now? It is because after this, we are going to have another chapter called rotation. Okay, so in that one, when you apply the force, it is going to give us acceleration also, and it is going to give us rotation also. Okay, so what? So it means is, when we talk about Newton's second law of Newton. Second law of Newton says, external force that you are applying on an object, that is equal to what? Rate of change of momentum. Or mass into acceleration. So mass into acceleration of what? Acceleration of center of mass. Till now, we never used this word. We were never doing it. We were doing this kind of a question. We were saying that, okay, there is a block and we are applying the force. Did we ever thought that where are we applying the force? No. Till now, we never considered. F is this is mass. We used to write F is going to give it mass into acceleration. Very simple. But this acceleration actually is acceleration of center of mass. Okay. So Newton's second law is actually like this. Till now, why we were doing it without it? Because we never considered that the object can rotate also. But in the next chapter, we are going to see rotation. So that is why we have to make ourselves very clear that what exactly its meaning. Okay, because if I tell you, let's take an example, so that it's clear to you that what is the need of this center of mass right now. Without it also, we are doing the physics and we are doing pretty well. So what is the need of center of mass? So okay, let's take an example. Suppose there is an object like this. Okay, there is an object like this, and I am applying the force from here, from the top. Now, what is going to happen? It is going to move forward. Yes, it is going to move forward, but at the same time, it can rotate also. It can rotate also. So that means if it's center of mass, if I put it over here at the center, then it is moving with acceleration. Yes, because of this force. Acceleration is there. But at the same time, this is going to rotate. Okay. So if I can take example for you, suppose, see, there's a book in front of me. And suppose this is the box here. Okay. I'll take it in hand only. Okay. Like this it is. And if suppose I'm applying the force, you can see the pen from here. What kind of motion is going to happen? I'm holding from the bottom, so it will not move ahead. Like acceleration of center of mass will not happen. But it will definitely rotate, see. Okay. It will rotate. So there is a rotatory motion also associated with that. So because of that, what happens? This point here, this point here, this point here, this point here. They are not going to move with acceleration of center of mass. They will move with some other acceleration. Its acceleration will be something else. 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 Then how to apply F equal to ma? That's why center of mass is required, so that we can write F equal to mass of this body. If it is m, then F is equal to m into COM. Understood that? So Newton's second law basically is not F equal to ma just. It is basically F equal to m into acceleration of center of mass. Okay, so first thing is, all the people, note this. Note what I have written right now. A point inside or outside the object where entire mass of the object is assumed to be concentrated. Okay, write that. In that one point is there where you can ask me that, sir, how outside? That point should be inside only. So there are certain objects whose center of mass lies outside them. That also we'll discuss. First, you note this. Completed? Completed, students?
Yes, sir.
Okay. So now the second point that we have to discuss is how it's outside. I have written that center of mass can be outside. So basically center of mass depends on shape of the object. Center of mass of the object depends on shape of the object or the position of mass. How the distribution of mass is there, it depends on that. Okay, let me write it. Center of mass of object depends on distribution of mass. Distribution of mass of the object. Okay, so distribution of mass is uniform, then it will be entirely in the middle. Let's see if we take that. Okay, suppose I take a ring. So if ring we are taking, this is a ring. If it's uniformly distributed, that means this entire thing is having same mass per unit length. Whatever is the mass here, same is the mass here. So what will happen? It will come in the center. Here is also same mass, here is also same mass. So it will form at the center. So it's a center of mass is at the center. Exactly same way if disk is there. For disk also. Ring, disk, sphere, okay, all will have their center of mass at the center. Which center? Geometrical center. Geographical center. No, geometrical center, not geographical. Geometrical center. Okay, exactly same way if suppose we say cube is there. So in a cube also, it will be at its center only. Okay, this is a cube. So where it will be the center of mass? At the center. Right. If we take a rod, this is the rod. So for rod also, where will be the center of mass? At the center, obviously. So here is center of mass. So these are uniform bodies. So where is the center of mass? At the center. But if it's a non-uniform, then it may not be at the center. Now, non-uniform means what? Suppose I have two rods. One is this rod and another one is this rod. Now, their center of mass we have to find. So their center of mass will be somewhere here. Now see, is it outside the body? Yes. How it will come? That you'll see. We'll find it in fact. When I'll give you the data, we'll find where is the center of mass of this thing. In fact, here also you see, if suppose this is a ring, then where is the center of mass? Is it within the ring? Because mass is over here only. Where is the mass? On the circumference. But where is center of mass? Outside the circumference. So that means this is the body. If I say this is a wire, is it in the wire? No, it's outside the wire. Okay, so center of mass will be within the body, not necessary. See, here it is within the body. If this itself become a disc, then this is within the body. But if this becomes a ring, then it's outside the body. So center of mass always is going to lie within the body, no guarantee. It can lie outside also. Okay, that point you have to remember. On what it depends? It depends on distribution of mass. How is the distribution of mass? Similarly, we can find out where will be the center of mass. Okay, so make this one also, then we'll proceed. Center of mass of object depends on distribution of mass. Completed?
Yes, sir.
Right. Now let's move ahead. One more thing we'll write about center of mass. Now I have written F equal to MACOM over here. I applied the force over there. Okay. So one more way we can define center of mass. What is that? It says, if suppose this object is going to move, okay, and acceleration is this we have written. Acceleration of center of mass is actually the total force that you have applied by mass. That's only the meaning. This only I have written. Okay. But if suppose I would have taken a point mass over here, a small mass, small point, and its mass is also m only, the same. And I apply the same force on this. Then what will be acceleration of this? What will you write? Acceleration will be F by m. Both are same. So it means what? Center of mass behaves like a point mass having mass of the object. Okay? Center of mass basically is what? Behaves like a point mass of the mass of the object, and it moves in the same way as a point mass moves. Who? Center of mass. I'm not talking about the object. Center of mass behaves like a point mass. Okay? And it moves in the same way as point mass would have moved on the application of force. Very, very important point it is, because that is how we are going to solve the numericals. Then only you will understand what is happening in the numericals on center of mass. Okay, so very important point this is. We'll note this one. So what the point is? Okay, center of mass behaves as a point mass, a point object, you write. Okay, if not the point mass, point mass having the mass of object, and it moves in the same way as point mass on the application of force. It moves in the same way as point mass on the application of force. On the application of force. Okay, then we can write like this. What I made the diagram. This is the point mass. Here we are applying F. So we are writing what? Acceleration is equal to F by m. This and this are same. Okay, note that one also. If doubt is there, ask. Don't hesitate in asking the doubt. Completed? Students, is it over?
Yes, sir.
Right. Okay. So little bit of idea we have now. Center of mass is there, something where entire mass is concentrated. If you apply the force on the object, then center of mass move in the same way as a point object would have moved. Its acceleration will be F by m. Okay, that much we understood. How to find center of mass of the object, where it lies. Okay, so next thing is we are going to see position of center of mass. Position of center of mass. So how to find it? So to find this center of mass, there were certain observations, certain practicals were done, experiments were done, and slowly they came up to a formula. But before that, what they did is they took two masses, say M1 and M2. They kept that at a separation of, let's assume it is R. Then they did experiment. Okay, so from the experiment, what they found? They found that center of mass is always near to heavier mass. Where center of mass lies? Near the heavier mass. So if I say in this one, M2 is greater than M1, let's assume, okay, assume M2 is greater than M1. So where will be our center of mass? Near M2. Maybe somewhere here. What is the observation? Observation number one is center of mass always lie closer to heavier mass. Okay, fine, no problem. That means position of center of mass. If I write position of center of mass, if I say RCOM is inversely proportional to mass. Why? Because if mass is more, the distance from the center of mass will be smaller. This distance. If I say this is R2, let's say, and this is R1. So position of center of mass will be closer to heavier mass. So I've written position of center of mass is inversely proportional to 1 by m. Or if I clarify this in more way, instead of writing RCOM, because I have written here R2, I'm writing it as R2 only, if you want, or let it be R. Okay, let it be R only. R is inversely proportional to 1 by m. That means position of center of mass will be inversely proportional to mass. That will be closer to heavier mass. Said okay, fine. Right? Fine. So then what we can do? Write R2 to 1 by M2 and R1 is 1 by M1. Then let's get the ratio of them. What is the ratio? R2 by R1 will come out to be M1 by M2. Or sometimes we'll be writing this M1 R1 equal to M2 R2. Fine. From where this is coming? This is coming from the observations that were done. Okay, there is no theory kind of that there is a law of this one. No, there is no law. It's an observation. Pure and pure what is observed from the experiments. Okay, so R2 by R1 equal to M1 by M2 or M1 R1 equal to M2 R2. Right, fine. First you note this one. Note this. Any doubt is there, ask. Because this is the developing stage. We are developing a concept. Okay. So if any doubt is there, any doubt is creeping up, ask. Okay, don't feel like it will be clear later on. No, ask it. Anyone? Any doubts, students? Okay, fine. So first note this one. Completed?
Yes, sir.
Right. Okay. So now we have done this. R is inversely proportional to M, R1, M1. We got one relation. This is the relation. Now I want a formula. This is the formula or not? This is the formula one. This is the conclusion. We will remember this. But other than this, we want one more formula for what? If suppose R is given and we have to find R1 and R2, or there is a relation, some kind of a relation, so that we can calculate or we can get between R1, R2 and R and involving M1 and M2, it will be better for us because here in this one, R is not there. R1 and R2 are there, but R is not there. So we should have a relation. So what we did, here from this one, we are taking out this R2 by R1 equal to M1 by M2. This relation is there. Now, what are we going to do in this one? We are going to apply one law is there in mathematics, which you don't study in mathematics generally. That's called componendo dividendo law. What is that? Componendo dividendo. Now, this particular law, apart from here, we will be applying in class 12 in optics. Optics means light. In light, we will study this again. So, if we know this, it will be great for us. Okay. So, what this law is, very, very simple law. You will understand it. There is nothing in it. Okay. So, see, this is basically the ratio. Now, what I want R also should be there. Now, check what is R basically. R is actually R1 plus R2 in this. So, somehow I need to get R1 plus R2. So, see what I am doing. Okay, this one, R2 by R1. I am writing it as R2 plus R1 by R1. What I did, I took this denominator, added over here, and kept denominator as it is. So what will happen? Same thing will happen on the other side also. What is other side? M1 plus M2 by M2. Right? Same way. Is it necessary to do it like this? I could have done it another way. Yes, you can do it. Another way also we can do. What is another way? Let's check. R2 by R1 is there. So R2. In denominator, I want to add. Okay, no issues. Add in denominator. R1 plus R2. Same way on the right side also. M1 by M1 plus M2. No issues. We can do that. Someone will say, I want to add in numerator also and denominator also. Fine. Add it. No problem in that either. That's componendo dividendo. Okay. You can add in numerator. You can add in denominator. You can add in both. But whatever you are doing on the left side, same thing will happen on the right side also. That is the law. That is componendo dividendo. Okay. I require both. So that's why I have written both over here. Third one I don't require. So I have not written. Okay. So see now. R1 plus R2 basically is what? R1 plus R2 is R. So put it over here. R by R1 equal to M1 plus M2 by M2. So what is R1 value? R1 value I am getting here is M2R by M1 plus M2. That's R1 value. R1 value is M2R by M1 plus M2. From here, I'll be getting R2 value. Just check. This R1 plus R2 is R. So R2 by R equal to M1 by M1 plus M2. So what is R2? R2 is M1R by M1 plus M2. So sometimes they ask you this question directly. Okay, R1 and R2 values. So if suppose I'll give you a question, okay, and that one we'll find R1 and R2 directly. Okay, so first you note it. Any doubt is there, ask. Done?
Yes, sir.
Okay, so let's use it now. Let's use this. Let's have first question. Okay, so then we have two masses. 1 kg and 2 kg. And separation between them is 8 centimeter. We have to find center of mass position. Find position of center of mass. Simple question. Find position of center of mass. What do you do? See on the board, I am doing it. First of all, which is heavier? 2 kg or 1 kg? Very simple. 2 kg is heavier. So where will be center of mass? Closer to 1 kg or 2 kg? Where will that be?
2 kg.
Right. It's closer to 2 kg. So here it is. Here is C1. Okay, fine. I said this is R2 and this is R1. So now we have to find R1 value. What is R1? Say R1 formula, I remember, it is M2R by M1 plus M2. When you're finding R1, you are writing your M2. Okay, M2R by M1 plus M2. So 2, this is M2, okay. This is M1 and this is M2. So 2 into 8 centimeter by M1 plus M2, 2 kg plus 1 kg, that is 3. So what are we getting? 16 by 3 centimeter, R1 value. Same way, say R2 also I want to find. One way you can find R2 very easily by 8 centimeter minus 16 by 3. Okay, that will come 8 by 3. Very simple, we can find 8 minus 16 by 3. But still, I want to use the formula that I have derived. Okay, so R2 is M1R by M1 plus M2. M1 means 1. R value again 8 centimeter. By mass, M1 plus M2, that means 2 plus 1, 3. So answer is 8 by 3. Simple. Are you able to understand?
Yes, sir.
Okay,
Yes, sir.
note that one. Note it. Completed?
Yes, sir.
Okay. Now, one more thing you understand in this. When I'm saying find position of center of mass for these 2 point masses. Okay. So always remember, when I'm saying these 2 are point masses, basically they belong to one system. They are a part of some object, definitely. Okay. That's why we are finding the center of mass. So this all is basically one system. Same way, if I say that we want to find center of mass of 2 planets, or we want to find the center of mass of the sun and the earth. So we are considering sun and the earth as one system. And then we are trying to find the center of mass. Okay, so any 2 objects when you make and they are finding center of mass, that means now it is acting like a system for you. And you are going to see them as a system, not 2 different things. Okay, that is the meaning of center of mass. Always remember that. Okay, let's move ahead. The same question, what we did right now, I'm going to frame in a different way now. What is that? Let's see. So again, 2 masses. These are 2 masses. This is 2 kg. Okay, and the separation between the 2 is 10 centimeter. Right, and center of mass. Center of mass is here somewhere. Okay, at a distance of 3 centimeter from this mass, whose mass is m. We have to find this m. Find mass of second particle. Find m, basically. What is m? Center of mass position given. Okay. Find mass of second particle. Okay, you people try first. Let us see what you are getting. Getting the answer?
Sir, I am getting 4.6.
You are getting 4.6. Okay. Is everyone getting the same answer? Okay, see on the board. If this is 3, then what is this? This is 7. Because total is 10. And I would say this is R1 and this is R2. I know R1 by R2 equal to M2 by M1. I know this relation. So what is R2? Here written 3. And R1 is 7. So 7 by 3 equal to M by 2. So M value is 14 by 3. That's it. This is one method. Okay, R1 by R2 equal to M2 by M1. I did 14 by 3 MVT. Otherwise, one more method is there. Now R1 and R2 both you know. Okay, then anyone we can use. Say R1. I want to use R1. So R1 is what? M2R by M1 plus M2. This is the formula. R1 value is 7. M2 I have to find. So M into 10 by M1 plus M2. That means 2 plus M. So what it is? We'll multiply here. 7 to 14 plus 7M equal to 10M. Take this one that side. There's 14 equal to 3M. So M equal to 14. Same thing. Whichever method you do, whichever method is you are knowing at that point, we can do it. Right? Everyone got the answer now? Yes or no, students?
Yes, sir.
Okay, so is this clear? Two point masses are given, they ask you center of mass, or they ask you mass of any object. We can solve this, right?
Yes.
Okay.
Yes, sir.
Right. So let's move ahead now. Now suppose in any of the question, they say there are 3 point masses and their center of mass you find. We will say that we don't know how to find. We only know about 2 point masses. 3 masses we don't know. Then what to do? In that case, we have got a formula for that. From where the formula came? From here only. From here only the formula came. How? Say it like this. For 2 point masses, this was M1, it was M2. Now till now what we are looking at, what is this gap between the two? But suppose it's not given, their positions are given. Okay, so its position, let's say, is x1 and its position is x2, or let me make it on coordinate axis so that you can understand in a better way. So its position is given to you, like this is R1 and that's R2. Like this position is given to us. Position means is x coordinate as well as y coordinate. So its x coordinate, suppose R1. R1 basically is x1 I cap plus y1 j cap. Let's assume. And R2 is x2 I cap plus y1 j cap. Let them be on the same line only. So y coordinate is same, x coordinate is different. Fine. Now what is the difference? If I ask you what is the difference between the two? Y coordinate is same. Okay. So what is difference between the two? Difference between the two basically is R2 minus R1. What is going to come? Y1 will cancel. It will come out to be x2 minus x1 into I cap, which we were not writing as R till now. Fine, this is okay. But how to get the center of mass? Every time I will not be finding out this. Okay, so what we learned so far, I'm just going into that point only, just check that, okay? We learned it if center of mass is somewhere here, we call this as, oh, R2 and R1 I have already used. I can't use R1 and R2. Huh? So, and X1, Y1 also I have used. So, what shall I use now? What other point is there? Okay, I'll use D2. That is the only thing I have now. And this is D1. Okay, so what we did, if suppose I want to find D1 value. So we were doing D1 equal to M2 into separation between them, total separation between them. That is R by M1 plus M2. This is what the formula we used so far. So far, they refined that. They say that we want to write it in a different way. What is that different way? Same formula in a different way. Means what? Say D1, let's write as M1 into 0 plus M2 into R by M1 plus M2. When we saw both, said, okay, we have no problem, we can write that. But what they did, when they write 0, it means they are observing the center of mass from M1. D1 is from M1 only, no? Center of mass position. That's M1. So M1 into 0 plus M2 into this distance, because this is the distance of M2 from where you considered 0. Okay, M1 in its coordinates, considering this as the reference, plus M2 into its coordinate, from where? From 0, by M1 plus M2. So use this. So that means somewhere you take reference, and from that reference, find out what are the positions of the two masses, and then put it into this formula. Okay, understandable. So then they come out. Presently, I am taking 0 over here. So I got this formula, but I don't want to consider this as 0. Then what? I am going to consider this only as 0. Then what you will do? Then also I have no problem. With respect to this, what is its coordinate? X1. And what is its coordinate? X2. So then this formula was changed into M1 x1 plus M2 x2 by M1 plus M2. Okay, this is the position of center of mass, RCOM. From where? From origin. Wherever 0 is there, from that, the formula becomes M1 x1 plus M2 x2 by M1 plus M2. If you want to write it in terms of vectors, yes, fine, we can. Same way for y coordinate, M1 y1 plus M2 y2 by M1 plus M2. So from where it came from this formula only of yours, which we discussed first. Okay, so when you do the experimentation, more and more experimentation, you get the formula as a proper formula or concluded formula, which we are going to use. Okay, so now this is formula of us. What is this formula? This can be used for any number of particles whose positions we know, and we can find their center of masses. Okay, so what you will note, for you, this all is not required. Okay, this was for you to understand. Once you understood that, then you'll be using directly this formula. Okay, so use that one. Use that formula. You can make this diagram. Okay, so RCOM is M1 x1 plus M2 x2 by M1 plus M2. This is what? X coordinate of that. And same way, if suppose y coordinate also we want, so RCOM's y coordinate, it will become M1 y1 plus M2 y2 by M1 plus M2. So now this is the main formula for us. Okay, note that. Completed?
Yes, sir.
Right. Now let's have question on this one also. And now we will not have question on two particle system. I'll give you more particles. So let's have 1 kg here. Its coordinates I'll write as 3,5 centimeters. Another particle you have 2 kg somewhere here. Its coordinates I will give you as 6,6 centimeter. Let's have third one also. Here, 3 kg. Its coordinates are 10,4 centimeter. So 3 particles are there. We want to find the center of mass. Okay. Find center of mass. Come on, everybody, note it and start solving. So what you have to give me? X coordinate of center of mass and Y coordinate of center of mass. Both you have to find.
Sir, I
Completed?
got the same answer, sir.
Are you getting the same answers?
Yes, sir.
Okay. So what formula we used? M1x1 plus M2x2
Plus M3x3 by M1 plus M2 plus M3.
yes, by total mass. Exactly same way for y coordinate of center of mass, M1 y1 plus M2 y2 plus M3 y3 by M1 plus M2 plus M3. Okay, fine. Now let's go a little bit into mathematical thing. Okay, what mathematical thing? Let's see. I'm taking one triangle. It's an equilateral triangle. There's an equilateral triangle here. One particle here, one particle here, and another particle here. Okay. 1 kg. 2 kg and 3 kg. Okay, and I'm giving you this is 6 centimeter. It's equilateral triangle. Okay. Now its center of mass is asked from us. Find center of mass of this combination of particles. Okay. Find center of mass of system of particles shown. particles shown. This we have to find. Okay, note the question. Noted?
Yes, sir.
Now, in this question, there is a problem. The problem is its coordinates I don't know. 3 particles are there, but its coordinates I don't know. And then what we have to do? First thing is, we only have to choose origin somewhere. We only. So the best way to choose origin is take any mass and assume it to be origin. Any mass. You don't have to go and search actually where is the origin. We don't know. Right? So make any mass as your origin. And then find the position. Okay. You can say me that, sir, if suppose origin is this one, then with respect to this, coordinates will come something else. If I'm going to take this as origin, coordinates will be something else. Or if I take this as origin, coordinates will be something else. Yes, with respect to that point, coordinates will be different. But center of mass will be at the same point. Okay, if I'm going to get the position from this one, so I'll also be getting the position from this one. I'll check. That I'll show you. Okay, don't worry. So first of all, now we have to choose the origin. So our point number 1, when we start solving this kind of a problem, what you'll do? Take any mass as the origin. Okay, take any mass as origin. You'll decide, okay, fine, this is my origin. Okay, 0, 0. First thing. Now then, what about the coordinates of other? We can write from here, what is the distance of this one? 6. So 6 means along which axis? This is x-axis and this is y-axis. So this is along which axis? The x-axis. So its coordinates will be 6, 0. Why? Because it has nothing along y-axis. It's not above this. It's on the same straight line. So 6, 0 is its coordinates. Fine. What about this one? This is equilateral triangle. So this should be exactly in the middle of this one, like this. So what is the coordinate of this? Say 3, 0. So its x coordinate also will be 3. Surely. Because it's on the y-axis. From this point. So here is 3, here is also 3. X coordinate. Y coordinate. For y coordinate, I need to know what is the height. I should know what is the height. What we know at the moment, this is 6, this is also 6, and this is also 6. Said, okay, this is a right angle triangle. Yes. Opposite to angle means what? Sine. And what is the hypotenuse? 6. So that means this will be 6 sine 60. 6 sine 60. Opposite to angle, sine component. Opposite to angle, sine component. Whose sine component? What is there in hypotenuse? 6 sine 60. Now 6 sine 60 means 6 into root 3 by 2. 6 into root 3 by 2. That means 3 root 3. So y coordinate is 3 root 3. That's it. You got the coordinates of all. I have the coordinates of all the masses now. Can we find the answer? Yes. So x coordinate of center of mass. Formula m1x1 plus m2x2 plus m3x3 by m1 plus m2 plus m3. So let's do that. 1 kg. This is 1 kg. 1 kg is x coordinate 0. 2 kg, 2 kg's x coordinate is 3. 3 kg its x coordinate is 6. By total mass, 3 plus 2 plus 1, that is 6. So what I am getting? 2 into 3, 6. 3 into 6, 18 by 6. Okay, so 24 by 6, that is 4. So x coordinate is coming 4 centimeter. Tell me, is it clear to everybody? Any doubt anywhere? Ask. Don't hesitate in asking. I'm saying again, if any doubt anywhere is there, ask me. Okay, so no doubt. So then go for y coordinate also. Let's find y coordinate. Okay, so y coordinate is here. We'll find it. Take the place. Y coordinate. I'm not writing the formula. Okay, m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. I'm not writing it directly. I am getting the answer, y coordinate of center of mass. So 1 into 0.
So root 3 centimeter.
Okay, okay. 1 into 0. Then 2 into 3 root 3 plus 3 into 0 again by 6. By 6. So what we got? 6 root 3. This is 2 into 3. 6 root 3 by 6. So answer is root 3 centimeter. So our center of mass coordinates are 4 comma root 3 centimeter from 1 kg mass. This is the position from 1 kg mass. Okay, note it. Done? Yes, students, is it over? Okay, take your time. Completed now?
Yeah, completed, sir.
Okay, everybody?
Yes, sir.
Have you done? Anybody is there who is still doing it? say something. Don't wait for others to say for your turn. If you have completed, say yes. Okay, don't always wait for others to say. Say about yourself. If you have completed, say yes, we have completed, sir. If anyone is there who has not completed, only who has not completed will say yes. Otherwise, I'll start. Anybody who has not completed yet? Okay. Right. So this was the case when I took this as origin. I might have taken origin somewhere else. But when you're solving the question, it will be clearly saying that from where they want to know the position of center of mass. So you don't worry about that if we are taking origin somewhere else, some other answer will come. No. They will ask you specifically where you should be taking the origin. Origin means is the point from where they want the position of center of mass. So don't worry. But still, if you have a doubt, no, sir, one more time we'll be doing it from some other position also. Okay. Okay, we'll do that. But you remember that what answer we got right now? It's 4 root 3. Okay, from 1 kg. Just remember that. Because center of mass does not depend on what is your origin. It depends on how are the masses distributed within the body. It depends on that. It doesn't depend on where you have taken origin. Okay, so just see. This will be, we'll be doing it as if we are solving any other question. Okay, so let's do that. Okay, so all the coordinates I have removed. So where is our origin? So origin I want to take, let's say 3 kg. 3 kg is my origin. Okay, 0, 0. It's my origin now. Now we have to write coordinates according to this. Okay, so this is 0, 0. So that means, how is our coordinate system? Like this. So this side if you go, that's positive x-axis. Above you go, positive y-axis. This side if you go, negative x-axis. So from this 0, 0, then its coordinate will be -6. And y coordinate is 0. Because it's on the same straight line, x-axis. This point is from here. Again, this point is on the left. Its coordinates will be -3. So x coordinate is -3 and y coordinate is same 3 root. So these are the coordinates. Now I'll start solving. Again, this time also I'll not write the formula. I'll just use it. Okay. So XCOM 3 into 0, 2 into -3, 1 into -6 by total mass, which is 6. So what I'm getting, 2 into -3 is -6, 1 into -6 is -6. That means -6 minus 6 minus 12 by 6. The x coordinate is coming -2 centimeter. Center of mass x coordinate is -2 centimeter. Okay. Y coordinate. Y coordinate will be same actually, √3 only. Check. 3 into 0 plus 2 into 3 √3 plus 1 into 0 by 6. So it's coming √3. So y coordinate, there is no problem. But x coordinate, there is a problem. There is -2 and √3. There we got 4 and √3. Then check out is the same thing. From here, -2 means somewhere here. -2 means this is 2. So from here what? It is 4 only, no? It's the same thing. So center of mass is not changing. Its position from different particles can be different. But center of mass is same. So whether you are finding from 1 kg, you are finding from 3 kg, whether you are finding from 2 kg, is the same point only. So you don't have to think that from this point, if I am finding its different center of mass. No, the same center of mass. But from that point, its position is different. That is the only difference over here. Okay? Is this clear to you?
Yes, sir.
Okay. Note this one also. This is kind of a second question on the same kind of problem. Then?
Yes, sir.
Okay. Now let's see. Another question I am framing. Question is like this. How many masses? 2 masses we'll take. It will be easy for us to solve. Unnecessary. Should not have too much calculation. Okay. So a 3 kg mass. 3 kg mass is placed at 2i cap plus 3j cap plus 4k cap meter, and 5 kg mass is placed at minus I cap plus j cap plus 2k cap meter. Find center of mass of the system. Okay. Find center of mass of the system. Note this question. Right, done that. Noted question.
Yes.
See, one method is find x coordinate of center of mass m1, x1, m2, x2, m3, x3 by m1 plus m2 plus m3, then going for y coordinate, going for z coordinate. I won't do that much. Who will do that much? Huh? More than 1 minute it will take. So what he'll do? All together. All together means directly I'm going to write RCOM. So M1 into R1 directly, that means 3 into that. 2i cap plus 3j cap plus 4k cap. Can we do like this in the previous question also? Why not? We can do. 3 into 2i plus 3j plus 4k plus 5 into minus ik plus j plus 2k. By total mass, 3 plus 5, 8. So what this is 6i cap minus 5i cap. 6i cap minus 5i cap. That means I cap. Then 9j cap plus 5j cap. 9 plus 5, 14. Plus 14j cap. Then 3 into 4, 12. 5 into 2, 10. 12 plus 10, 22. By 8. That's all. Game over. What is x coordinate? Said x coordinate. X coordinate of center of mass is 1 by 8. Y coordinate of center of mass 14 by 8. Z coordinate of center of mass 22 by 8. Finished. So what? Understood that?
Yes, sir.
Okay, note it fast. Done?
Yes, sir.
Right. Now, so far what we did, we found out center of mass of those systems in which we were knowing that some particle is here, some particle is there, some particle is there. Their positions were given. We were able to find center of mass. But if uniform object is given, then what we have to do? There is a uniform object, or maybe an object in which mass is varying, different masses at different position. Then how to find center of mass? Okay, so heading is center of mass of uniform and non-uniform objects and non-uniform objects. Center of mass of uniform and non-uniform objects. Now, first we will take uniform object. Okay, let's say a rod is there, a uniform rod. Uniform rod means like this. Now, its center of mass, I know it will be in the middle. But what are we trying here? We are trying to understand how to get the formula to find out. Okay, let's say its mass is m and length is l. So what I know already, it's there in the middle. It's a uniform thing. It has to be in the middle of that. We know. But what is the formula? Fine. So till now what we know, x coordinate is m1, x1, m2, x2, m3, x3, m4, x4, whatever the particles are given. Okay, that formula we know, m1, x1 plus m2, x2 by m1 plus m2. But in this rod, how many small or tiny particles will be there? It's infinite. Because particles are there from this point to this point. Infinite particles are there. Okay, then am I going to do like this, m1, x1, m2, x2, m3, x3, m4, x4 for infinite times? Who's having that much time? Who's having? Okay, we don't have. So first thing is, as usual, we will decide where is the origin. Okay, so origin we can say somewhere in the end. Check, this one is our origin here. Okay, it's a decided origin. The reference is required because from this position we are going to find the center of mass. Now, all the particles, am I going to give the positions? Not possible, infinite particles. So what he'll do, take any one particle, somewhere. And okay, so particle also is of the rod. So its shape also need to be of the rod shape. So that means I'm going to take this over here. I'm cutting it. And I'm saying, okay, this is my particle. This is my particle. Okay. I have decided this is my particle. Good. What is its mass? I'll say it's very small, so its mass I'll assume as dm. Its mass is what? dm is its mass. Simple. Okay. What is its position? So its position is x. From origin, its position is x. What I'm doing, everything I'm assuming. Mass is dm, position is x. Okay. Let's write its center of mass now. So when I'm writing center of mass, let it be x only at the moment. So x coordinate of center of mass. What is the formula? m1 x1 plus m2 x2 plus m3 x3. Okay. So here what we have, this is dm particle. And like this dm particle are right from this point to that point. From this point to that point. So many dms are there. So what we are writing? X coordinate is dm into x, m1 x1. And since there are infinite particles that we have to add, so then in mathematics there is one solution of that. If you have to add infinite particles, we call it as what? Integration. It does the work for us. So what we have done, m1 x1 m2 x2 m3 x3 m4 x4, we have written by writing just integration of dm into x divided by total mass. So directly we can write total mass, or you will see in the books it will be given like this. This is basically what? Total mass, nothing else. So m1 x1 m2 x2 m3 x3, everything we have written in the form of integration divided by total mass. This is the formula. For y coordinate, dm into y by integration of dm into y by dm. Z coordinate, integration of dm into z by dm. That's the formula. Now let's see, we are going to find it first. Is it necessary for us to find out, learn how to find for different positions or different objects? No, not required. Then why are we learning this? For non-uniform objects. One question we'll do on non-uniform, but before that, let's learn how to do it. Okay. So x coordinate of center of mass is dm into x by dm. Fine. This is the formula. So formula means we have to put it inside the important thing. And now let us start solving. I am solving it even though I know where is its center of mass. It's in the middle at L by 2. From this end, it will be at L by 2. Let's see whether it's coming or not coming. Okay. So first thing now, this is dm. Now what is dm meaning? How to get its value? So for that, what he'll do, he'll say that, okay, fine. dm is there. It's a part of the rod. Rod is having length L. So what is the length of this dm? Let's say its length is dx. How come dx? Because if this point's coordinate is x, then in this point's coordinate will be something x1. So length will be x1 minus x only. The difference between x coordinates. So dx. Right. Now what? What is dm? Very simple. dm is the mass of dx length of rod. Dx length of rod. Okay. Correct, that is no doubt about that. What we know? We know that L length of rod. What is the length of rod? L. L length of rod is having mass m. Has mass m. Okay. Then, so dx length will have what mass? That is only the dm, no? dm is the mass of dx length. L length is having mass m. So, unit length will have what mass? M by L. That's what we have learned. So then dx length? Dx length will have what mass? M by L into dx. We have done this before, but do it one more time. There is no problem in it because you are learning it. Okay, so L length is having how much mass? M. Unit length will have M by L. So then dx length will have what mass? M by L into dx. Tell me, is it clear to you?
Yes, sir.
Okay, now what I'll do, I'll just put it into this formula, nothing else. This is our formula. So x coordinate of center of mass, xcom, dm value is this. Put it, m by L into dx. Then into x. X is what? X coordinate. So x into x. M by L is constant, so I have taken it outside only. Divided by dm again. So what is it? M by L into dx. Like this. M by L and M by L cancel it. Now, from where to where we have to integrate? Where to where we are going to find the particles. Particle will start from this position and right from here to this position. So when you are at this position here, what is x value? Say 0. When you are at this position, what is x value? Say L. So we are going to get these kinds of dm particles from 0 to L. So that is only our limit. 0 to L. 0 to L. That's it. X dx. Its integration is x square by 2. So x square by 2 limits 0 to L divided by dx. Its integration is x. So x 0 to L. Put the limits now. First, L as x. So L square by 2. Then 0 as x. 0 square by 2. So what are we getting? Where shall I do? Where shall I do? Let it make this smaller. It is very big. Okay. Made this small. So we got a place. Right. So now we place it. It became L square by 2 minus 0. In the denominator, L minus 0. So what we got? L square by 2 by L. L and L gets cancelled. What we got? L by 2. We were knowing in the beginning itself. Yes, we were knowing. Then why we were doing? We were learning how to find it. Okay. So center of mass position is what? L by 2. And we have got for uniform and non-uniform objects. This is the formula that we are going to use. Okay. Note that. If any doubt is there, ask. Completed. Completed, guys?
Yes, sir.
Okay. So uniform objects, we were knowing center of mass is where, but still we found so that we can get to the formula. And if the question is asked on non-uniform mass, still we can do it. So first, today, we are going to see the center of mass of all the uniform objects first, and then I'll give you a question on non-uniform mass, in which we have to calculate where is center of mass. Okay, so first COM of uniform objects. All uniform objects. We are not finding it, okay? It's not required. So rod we already know, so but still I'm writing first is rod. Rod, let's say it's like this. Center of mass is exactly in the middle. If its length is L, then center of mass is at L by 2. We found it a little while ago. Okay, second one, ring. This also we discussed already. At the center. Disc, again at the center. These are all uniform objects, okay? Fourth, hollow sphere or a solid sphere, against center. Solid or hollow sphere, again at the center. Right, triangle. Triangle. Let's say equilateral triangle we are making. Okay, equilateral triangle of height h. Center of mass will be at height h by 3. Actually, center of mass is the intersection point of medians. Medians of this. Okay, what is center of mass of triangle? Intersection point of medians, which we call as centroid. Okay, intersection point of medians, or you can call as centroid. But what is its position? H by 3 from the base. I gave you that formula. Remember that. Sixth, cone. Okay, its height is h. Then where is center of mass? H by 4. From the base, h by 4 height. Okay, then cube and cuboid, again center. Center. Cube or cuboid at the center. Note that do we have to remember all these? Yes. Most of the things are at their centers only. So only selected are there, selected few, which we have to remember. Okay, like triangle is there, cone is there. After this, I'm going to show you hemisphere, semicircular disc, semicircular ring. Okay, those all we have to remember. Completed? Students, is it over?
Yes, sir.
Okay. So it's cube we have done. 8th cylinder. Cylinder is like rod only. Okay. So we can say it will be in the middle for that also. Hollow or solid, whichever you take. Okay. So in the middle. Or cylinder also. Then semicircular ring. Use semicircular ring. Radius r. Okay, so its center of mass is here. What is this height? This is 2r by pi. From the center, from the base, its height is 2r by pi. You have to remember it? Yes. Semicircular disc. It's a disc. Okay, its center of mass. Its radius is also r. First, its radius is r. Its center of mass is also somewhere here. What is this height? This height is 4r by 3 pi. This is 2r by pi. This is 4r by 3 pi. Same way, hemisphere. Solid hemisphere. Solid hemisphere will be like this. Okay, its radius is also r. Its center of mass is also somewhere here. And what is this? This is 3r by 8. Hollow hemisphere also we can make. And its center of mass will be at r by 2. Okay, hollow hemisphere. 12th. This also something like this. This is r. Center of mass is here. This is r by 2. Hollow hemisphere normally is not asked. Okay, but all other things are very important for us. Semicircular ring, semicircular disc, solid hemisphere. So their center of masses we should remember. 2r by 5, 4r by 3 pi, 3r by 8. Okay, note this. Completed? Students completed?
Yes, sir.
Okay, so let's finish today's class here. So tomorrow we'll be seeing non-uniform object and we'll use that formula. So when you come tomorrow, just go through this all formulas because we'll be solving the problems on that. Okay, problems on based on these formulas also. Okay, so that's it for today. See you tomorrow. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.